Yeah, we woke up quick. At noon, a ship A, oh, that's a nice ship. At noon, ship A is 150 kilometers west of ship B. So I guess that's A. And here's ship B. It needs to look different. Yeah, this ship, its ceiling's missing. That's ship B. Yeah, I'm different. Ship A is sailing east. Is going this way. Yeah? So the distance between them originally was 150. This boat, ship, craft is going that way. Sailing east at 35 kilometers an hour. What's that 35 kilometers an hour thing? It's a rate. But which rate? What way is it going? It's going right. It's going in which one? X direction or Y direction? It's going in the X direction. That's dx dt. dx dt is 35. Rad. Ship B is sailing north, which is always up. I'll have to tell you the story about misdirection. But anyway, did I already tell you that story? Which way's north? Up. I'll tell it later. Remind me. This one's going up. Is it Tuesday? Okay, is that the change in Y or the change in X? That's the change in Y. That's dy dt. And that specifically is 25. All right. Oh, they want to know how fast is the distance between the ships changing at 4 p.m. That's a specific t value. Oh, I think they like t. Anyway. Is that a t? No. That's a time. We're going to have to find some values. But what? We've got this triangle. And then that's the thing that we're going to set up. That's the equation that we're going to take the derivative of. Okay, so let's redraw that. Triangle. And then we'll label those triangles, because this is where we need to find stuff. Find stuff. What do we have? We have x squared plus y squared is d squared. We're going the distance. I don't know what that is. I'm trying to lasso this. Cut it. Paste it. Oh, I'm learning tricks. Okay, anyway. That's the thing that we're going to take the derivative of, but we need to label these sides too. What's this x right here? What's the x distance? It's going 150 kilometers an hour. How long is it traveling?
It's going 35 kilometers per hour.
It's going 35 kilometers an hour?
The distance is 150.
The distance is 150. That's how far apart they were. Oh, okay, it is 150. What's the y distance?
100.
Is it 100?
It's going 25 kilometers per hour, and you're going 4 hours.
It's going 25 kilometers an hour, and it's 4 hours. So that's 100. I see what you did there. See, this ship has sailed. Boom! Yeah, the same with the other ship. So that's not right. It was originally 150.
Now it's 0.
Does it go all the way? In 4 hours, what's 4 times 35? Is it really? It's 140? 140? So it comes up just shy? Oh, get this. That's not 150. What is it? 10. Picture not to scale. We're going to use those values later, because that's going to give us our x and that's going to give us our y after this ship has sailed. But we're looking for how much the distance in between them is changing. So now we take that derivative implicitly. That's 2x dx dt plus 2y dy dt. That's going to be 2d dt dd dt. That's fun. dd dt. Ted DiBiase. See, Nikki uses that reference, and I don't think any of our listeners even know who Ted DiBiase is. Anyways, what are we looking for? We're looking for the rate of change of the distance. We're looking for this. So if you see it, tell them we're looking for it. We need to find this other piece. What do we have? We have our x. X is 10. We have our y. Y is 100. We have our dx dt. What was dx dt? That was 35. And we have our dy dt. What was our dy dt? 25. Sure. But what do we need? We need that d. So let's go get that d. We're going to get that d with our Pythagorean 10 squared plus 100 squared. That's d squared. But we can get that d. We're taking the square root of that. What is that? Is that 10 root 11? Ten root 101? Ten root 101? Yeah? Somebody. Math is not a spectator sport. Get in there. Get dirty.
10 times the square root of 101.
10 101. 10 times the square root of 101. Look at that. That's D. And now we're almost done, because we're at the plug it in stage. We're going to go ahead and we're going to plug all that stuff in. So that's 2 times, what was my x? Not important. No. 10? dx dt? 35? Plus 2. What was our y? 100! Our dy dt? 25? And then that's going to be equal to 2 times 10 root 101 and times d dt, d dt. Psh. Squeeze that in there, because that's the thing that we were looking for. Can somebody pound that out? That's 2 times that's 700 plus 500. 5,700 on the left? 5,700 on the left, divided by 20 root 101. What does dd dt turn out to be? Give me decimal. Oh wait, you said what? 285
Over the square root of 101.
over the square root of 101. And of course, we'd rationalize that if we wanted it exact. But what's it about? 28.3? It's about 28.3. What were our units? Were they G's?
Kilometers per hour.
Kilometers per hour? Bam! Oh, fail. A box. That box missed it. Let's try this box. Boom. Box and flower.